about the system itself, because you said the system that you're working on was actually based on an older system that wasn't even United States. It was built on a European system, right?
It was actually, yep.
Uh,
Um,
Go ahead.
do you want me to get into it now before the break?
Yeah, and then we'll just come back. We just roll as long as we can.
Okay. So basically, I can't talk about specific stuff, obviously, but
Of course.
NATO Sea Sparrow, its involvement on who created it is in the name itself, the NATO community. All right, there was 13 countries specifically that were involved in helping create this weapon system. It was originally created as a point defense weapons missile system, and it was used, during coming out of World War II. Because we had a lot of threats with low-flying aircraft, just launching at us and getting out of there, and we had no way to really combat it. So one of the things that you mentioned is the fact that we had some European countries help us. Specifically, one of the things that is a part of our system is our computer, how we actually, solve the fire control problem, how we, go in and actually put a missile on a target. And that computer was basically retrofitted from a Norwegian tank. And it was built specifically for that tank, and it was just repurposed later on for obviously this system. But if you look at it, any tank is actually built upon a planar model. It's built on an X and a Y coordinate system for like artillery shots.
Yeah.
And if you look at it, I mean, when that gets repurposed to a missile system, and we have much further range than obviously a tank does on being able to effectively put a missile on a target, you would think that we would have to account for the curvature of the world, because it's got to be able to maintain a proper course to get to the target.
Okay.
And that's just not something you observe.
Wow.
It almost sounds like they had leftover parts like that Bradley infantry fighting vehicle, that fiasco, the Pentagon Wars.
Yeah. Well, this is really interesting to me. I'm kind of a fan of military technology anyway. So a Norwegian tank, they use the software, the algorithms, the firing algorithms, and the Norwegian tank everything was based off a plane, not shooting on a curved surface, but a plane. And then they retrofitted it for the United States Navy missile system. And that system didn't change anything. All they did was they extended the range on it so that you could fire missiles, much longer than an artillery shell. But the point was, it's still firing with a plane, dealing with a flat model for the software. Correct?
Yes, up until a point. And what I mean by that, let me elaborate on that a little bit.
So where we left off with you, Robert, was that the Norwegian system, the Norwegian tank system that was retrofitted for the United States Navy Sparrow missile system, which I find fascinating in itself. It's like, what, you're not going to spend the money and write a whole new thing of software? Is nothing really changed when you moved from the tank? Not much changed. Moving from the tank model to the ship model, all they did was extend the range, because the Sparrow system has longer ranges than any tank, right?
Yes.
Okay. And it does not account for what I think you mentioned earlier. It does not, and please feel free to expand on this. It does not take into account the Coriolis effect. Is that also true?
That is correct.
Can you give us anything on that?
Yeah. Basically, the main thing whenever they repurposed that Norwegian tank's computer, the only major thing they really changed, none of the hardware changed for it. The only thing they changed around is the software, and that was just to integrate for a missile system being used instead, because obviously we got more ammunition readily available, like we have 8 missiles instead of 1 barrel.
Yeah.
We have different peripheral pieces of equipment other than just onboard equipment with a tank. So the software was changed to run through the same hardware. And I know some people know what I'm talking about with that. But, basically, when you can't change hardware, your software is limited. And that's with any computer,
Yeah.
And so the only thing they could really implement with that, like you said, is a further range because of the missile itself.
Yeah.
But yeah.
Wait, can I ask a
Oh,
question real quick?
yeah, go ahead.
The targeting system on the Norwegian tank, that was for like a tow missile system or a Hellfire, or what kind of, for a missile, right? Not a projectile, not like a
For
shell.
the Norwegian tank?
Yeah, was it for a shell or for a missile system that was mounted on
It
the
was
tank?
for a shell.
Okay. No, because I think that's important because a missile has, a rocket on the end of it, right?
Yeah.
So it's a different thrust vector and all that. I guess I don't know if that's the right term, but a shell, you're accounting for it dropping, right?
Yep,
Yeah.
and you account for missiles dropping too, but basically you have a solid propellant in a missile that burns out to a max distance, But once it's in the air, it has onboard guidance to adjust its wings to basically inertial nav to the target.
Yeah.
And yeah, basically the Norwegian tank, that computer that was repurposed, its whole purpose was just to fire shells, a standard gunpowder shell, sabot, and that was it. And basically that was, we all know and can look back to artillery and cross-reference this. Artillery is always done from a plane or module. It's never taken into effect with Coriolis effect and, curvature of the world. Even though you hear those buzzwords all the time, you can look back on many articles from professionals that's done 20 years in the Army and worked with howitzers and all that stuff. They've never once taken the Coriolis effect into consideration.
And that's a good point to bring up. I'm not cutting you off. I just have to add this in, though, because I did get a letter from, he's obviously not there doing an interview. I wish more military people would come out and talk about this. But I got a letter from a howitzer, guy out that was stationed in Fallujah. And he said, and I remember reading it for Jonathan, and I think I talked about it on air a little bit, where he said that, the fire control, the computer takes over, of course, but there's someone always doing a manual calculation right next to it. And he was part of that team, and he said, look, that guy that's doing the manual stuff, he never took into account that the Earth was spinning, ever. And he goes, I don't know where, in fact, it's almost like it's just been passed down from generation to generation, kind of like one of those whispers. It's like, oh yeah, they talk about it like, oh yeah, we have to deal with Coriolis effect, but nobody actually does it. It's just one of those things that, in case anybody asks, it's like, oh yeah, we account for that. But what you're saying is basically confirming what he's saying. He's in the Army, you're in the Navy firing missiles, he's firing artillery shells, and you're saying curvature, or I'm sorry, the spinning of the Earth doesn't factor in at all to the calculations.
No, it doesn't. And like I said, just to kind of put that whole nail in the coffin on the Coriolis effect, in my, from what I've seen, what I've observed, I think it's almost like it's a buzzword, like it's just a cool thing to mention, like, oh yeah, we take shots so accurate from so far away, and we even have to account for the curvature of the Earth and, the spinning of the Earth just to, prop it up like it was such a impressive, feat to obtain. And I think that people just kind of went along with it. And like you said, since so many people, the whole parroting community that we have today, they're just like, Brock, Coriolis effect, and
so
that's really what it is.
Yeah, it's a good news story, but you're basically saying, look, I fire this stuff. It isn't there. It does not happen, and you're not firing. It's not, people. I'm not kidding. When I first heard about the sniper stuff, that the snipers have to account for Coriolis effect, I'm going, what are you talking about? I shoot. I've never heard nor read an article nor seen any calculation, and I've read a lot of firearm periodicals in my day. And so when the artillery guy came out, it was like, oh yeah. And then when your stuff, we're not gonna say exactly the range of the Sparrow, but the Sparrow fires way longer than artillery shell. Look, if it doesn't account for the Coriolis effect with the Sparrow, you're never going to see it after that.
But wait, we're talking about line of sight targeting or GPS for the projectile, for the missile.
For the missile, it's line of sight targeting. That's basically, like I said earlier, we track the target with a illuminator, and it's basically just another piece of gear that's tied into ours. And once we lock up on the target, we're line of sight pointing straight at it because it's a 2-degree pencil beam. It has to be pointing straight at it because if it's not going to see it. It's not a search radar. It's a fire control radar. And, if you're supposedly looking at something, 50 nautical miles away around a huge curve,
Yeah.
it's just you can't punch through the ocean with RF.
Well, Mark, can I ask one more question?
Yeah. Go.
The reason I ask is because I'm thinking about the Navy railgun that was fitted on the, I think, DDG 1000s, and
Yes.
I don't know, would they be able to use the same system, or do you know if they have something similar? Because it seems like if the world is flat, what the hell do you need GPS and accounting for a curve? And that thing's supposed to fire at like 5,000 or 6,000 miles an hour, I think, like Mach 7 with those projectiles.
Yeah, it's pretty ridiculous. And basically, the way I look at it is this. I won't claim to be an expert on that new system. It's kind of being prototyped right now.
Okay.
The railgun.
But, yeah, the railgun.
Yeah.
And basically, though, it follows along the same principles as a 5-inch gun that's already in effect for the Navy right now. We use a 5-inch cannon, and, we can do defilade shots and enfilade shots where we can fire over, mountains and make it fall back down and stuff like that. It's the same principle. All you're applying is a faster speed, and faster speed equates to a greater distance. Instead of having to be 20 nautical miles away from a target, you can be like 50 or 70 nautical miles away. And that's really what it plays into. And, I've even seen articles on that myself where it talked about it being more of a less of a littoral ship, like happened to be right off the coast and could be used readily available for other assets because it has such a great range with that. And I think it's more playing into that. It's not necessarily anything to do with curvature, Coriolis effect.
Wow.
That's amazing. So real quick, because I want to review it, because again, I know we're going to be kind of beaten on this, but this is important information, and repetition here is the only way we're going to get through to some people. So when you're using the Sea Sparrow system, the missile system, the missile is not guiding itself. You are guiding it from the ship with a 2-inch beam, right?
We actually are using a 2-inch beam. And basically how it works is we have a frequency that we hit the target with, and then the target reflects that frequency. It reflects the RF. And when our missile's in the air, our missile sees that reflected energy, and then it hones in on it and makes its own onboard adjustments.
Got it.
Based upon the reflected energy.
Is it two slightly different frequencies so that it has a collision point?
I can't confirm.
Never mind. I'm sorry. I don't know anything.
You're good.
I don't know what the hell I'm talking about sometimes. I'm sorry.
You're good.
I'm such an idiot.
I'll just tell you this. I can answer that partly. We have to use the same frequency. But once our missile does get to a certain point, it has point detonation, and this is all stuff you can look up. It has point detonation, and it has a proximity fuse. And the way a proximity fuse works is it actually has a small low-band transmitter on the missile. So once it gets within its terminal range of the target, it will make an illumination itself and determine where the target's at more precisely. And then it will explode if it's close enough.
Got it.
Nice, Jonathan. You out-geeked me on that one.
Oh, yeah. Well, we can talk later.
But the point is that the 2-inch beam, you have to have it on there for most of the trip. That thing's
Not
out
most,
there.
all of it, pretty much.
Okay, all the trip, except for the last couple seconds, if that. You can pull it off if you had to.
If you absolutely had to, but you have to understand, if it's not close enough, if you pull it off, the missile will go ballistic on its last update, and it might not hit the target.
Got it. And so if what you're basically saying is this 2-inch beam, what you're painting the target with, is you guys, when you're firing this thing out there, you do not account for curvature. That beam shouldn't be able to reach a target at a certain at whatever the at 50 miles should not be able to hit that target.
Yeah, and this is a perfect thing, and I'm really glad that I was fortunate enough to work on this, because the argument always is, well, we can reach over a curve because we're a search radar and we use atmospherics and bounce off different parts of the atmosphere, and then it comes back down. Okay. Now, see, the problem with that is this can't happen with a 2-degree pencil beam. The angle of this cannot put RF up into an atmosphere and then bounce it back down and then expect to get it back so we can properly track.
It's too
precise. Too precise.
Yeah.
It's too precise. It can't do that.
Yeah. Wow.
Wait a minute, I thought that's why they trained us all on Pong and games like that back in the 70s.
Because you can bounce stuff off the off the ceiling. And normally I would, if you had and please feel free to chime in on this, Robert. But if it was a wide angle beam, you might be able to do it. But as far as you know, they're not using that sort of technology to bounce something off the atmosphere and then track it from there. Otherwise, you'd probably be using it, because this stuff the Sparrow system's currently in use by a whole bunch, by all of NATO, right?
Yeah, quite a few different countries. And one thing, there are other radar systems that we use that are actually, and let me just explain this before I go on. There are search radars, and then there are tracking radars. And a search radar has a much wider band of just kind of blanketing the sky with RF so it can find something, as where a tracking radar is way more precise. And basically there's a communication between the search radar and then the tracking radar. Once the search radar finds that bearing and elevation of a target, it hands it over to the tracking radar through the computers, and then the tracking radar slews immediately out to where the search radar told it to go.
Exactly.
Yeah.
Now, and that's basically how it works in layman. But I think there's a wide band.
I think that's why
it doesn't account for it.
I'm sorry.
Some of our search radars boast distances of being able to track stuff like over 200 miles away. So take that into consideration for supposed curvature. This is something to think about.
200 miles. Yeah, I haven't even looked at the thing at 200 miles, but that's a massive distance. That's I think that's a full-blown mile below the horizon if the world was actually round.
Mm-hmm.
If I'm not mistaken, which, you shouldn't be able to hit it. Should not, unless, again, what you're talking about, bouncing it off something, which what you're saying it does not do. Let me ask something else, because you and I hadn't really, and again, if you can't talk about that, that's fine. But yeah, you specialize in the Sea Sparrow surface missile system, but you probably have had exposure to all sorts of different weapon systems from the ship point of view, both short range and maybe even a few that are longer range. Do you guys compare notes? I mean, do you kind of see the same sort of thing where everything's consistent? It's not like one system is using curvature and the other system isn't. Nobody's using curvature on anything, as far as you know.
As far as I know, we do not. I'm glad you mentioned that, because other systems, if you want to compare them, the only thing we feed into our systems at all, and it's only on a plane system. We have this piece of equipment, and I'm sure quite a few people are familiar with this, but we use gyros, right?
Okay. Yeah.
And these gyros are powered on our ship, and basically they stay stationary once they're spooled up, and we have to power them up before we get underway.
Yeah.
And this information from this gyro is fed into all of our radar systems and all of our weapon systems, and all they account for is the pitch and roll of our ship. So we can account and send that information to, compensate, like if our ship takes a huge roll, it compensates our weapon system to aim higher, if need be. And if you look at the coordinate system for that, there's no curvature in that at all. It's just a plain model.
That's great. Wow. So basically what he's saying there, folks, in case you've missed anything yet, is that there are no weapon systems currently in the U.S. Navy that are using curvature, or the Coriolis effect. It's something we've suspected for a little while now, but nobody's actually said it. And